Hello kids, today we are going to learn how to prove that a certain number is irrational. So what we are going to do is use a theory of contradiction. So basically what it means is, let's say in a basket you have apples and oranges and one fruit is given to you and it said prove it's an apple. You say okay, no, you know what, I'll try to prove it's an orange. And if I fail to prove it's an orange, then it's an apple. That's what exactly we are going to do. So we'll say I assume root 2 is rational. Okay, when I say root 2 is rational, what does it mean? I say root 2 can be represented by p by q. Okay, these are two numbers. Now I can also say root 2 is equal to a by b. Okay, where a and b are co-prime. What does that mean? That between a and b only one is a common factor. Okay, so let's say root 2, here p could be 18 and q could be 16. Okay, so now if you look at it, you have common factors like 2 9s are 18, 2 8s are 16, right? So 2 is a common factor. So these are not co-prime. But here if you look at 9 and 8, is there a common factor? No, right? So it becomes co-prime. The only number common between them is 1. So we can write 9 into 1 and 8 into 1. So I say root 2 is equal to a by b, which are co-prime, that is they don't have any number common other than 1. Now this is important because based on this we are going to prove something, that root 2 is irrational. Now the next thing I need to do is, we know it's difficult or it's not a pleasant thing to work with square roots, right? So what I'm going to do is square both the sides. So root 2 square is equal to a by b square. Okay, so that makes it 2 is equal to a square by b square. And if you rearrange it, it means 2b square is equal to a square. Okay, so this is our next important milestone here. So now what does this say is b square and a square, right? So which this particular term means that a square is divisible by 2. Let's say how you can show. So now what does it show you here? That 2 is a factor, or a is divisible by, a square is divisible by 2. Okay, so you can write it like this also, a square by 2, that is a square is divisible by 2. Now we know the fundamental theorem of arithmetic, which says if a square is divisible by a number, let's say p, if a square is divisible by p, then a is also divisible by p. Okay, so if a number's square is divisible by a certain number, then the number itself is also divisible by that number. So which tells me that a is also divisible by 2. Okay, this is fundamental theorem of arithmetic. Okay, now let's move further. So now what does this mean? Ki a has a factor 2, so let's say a is equal to 2c. Okay, so let's say 18 by 2, what is that? 9. So now my c becomes 9, this is 2 and my a is 18. So you get that? So it says we don't know what this c is, right? But there is certain number when multiplied by 2 gives you a. Okay, so there is some number c when multiplied by 2 gives you a. So now I have to remember this. Okay, Now we did a is equal to 2c. We also had what? We also had 2b square is equal to a square. Remember, when we squared both the sides, we got 2 is equal to a square by b square, and then we did 2b square is equal to a square, this, right? So this is another important part. So now using the same thing, we have 2b square is equal to a square from the previous steps. Now we said a is equal to 2c, so now I replace a by 2c. Okay, so 2c square is equal to 2b square. Are you following me? So now 2b square is equal to 4c square, which is b square is equal to 2c square. Now what does that tell me? That b square by 2 is equal to c square, which means b square is divisible by 2. Or 2 divides b square. Therefore, b is also divisible by 2. This is what we discussed, fundamental theorem of arithmetic. Okay, so b is also divisible by 2. What does that mean? That b has factor 2. Okay, we did earlier a has factor 2. So this was a has factor 2 here. Okay, in this previous, when we do a has factor 2, when we did a is equal to 2c, so 2 was the factor, 2 into c, so a has factor 2. Now we proved b has factor 2, so which means a by b, a and b both have a common factor 2. A and b both have common factor 2, but this contradicts our initial matlab it does not align, it's opposite, contradicts our assumption a and b are co-prime. Now what was co-prime? That between a and b only one is a common factor, but here we proved a and b has two factors, 2 as a common factor. So now since it contradicts our assumption, therefore what? Therefore root 2 is a irrational number. Okay, therefore root 2 is irrational number. Why it's irrational? Let's go through it again. Because our assumption that root 2 is a rational number is proved false, because we said a and b have only one as a common factor, but it turned out it has 2 as common factor. Let's revise it from the beginning. So we started here, we said root 2 is equal to a by b, where a and b are co-prime. It was something p by q, and then after you divide, you bring it to the co-prime, to the prime factors, it's left with a and b. Okay, so the number, the only thing common between a and b is 1. Like what is common between 5 and 7? It's 1, right? 5 and 7 are co-prime because there is no factor common. So here we say root 2 a by b is co-prime. Now A and B are co-prime. So this is our main thing. Like I said, this is going to show us the contradiction. Now we square both sides. Root 2 square is equal to A by B whole square. Now root 2 ka whole square makes it 2. A square by B square. We cross multiply, we get 2B square is equal to A square. Now next we say B square is equal to A square by 2, or A square is divisible by 2, or 2 divides A square. What does that mean? That 2 also divides A. Okay. What does that mean? That 2 is a factor, A has a factor 2, or 2 is a factor of A, or 2 is a factor of A, or A has factor 2. Okay. So this shows the first part, that A has the factor 2. Now let's move on to the next part. Now we say okay, fine, A has factor 2. So let's see. So that means A is a multiple of 2, right? 2 into something. So we don't know what that something is, so we put it as C here. So A is equal to 2C. So this is our part 1. Now we had earlier done, when we squared and cross multiplied, 2B square is equal to A square, right? 2B square is equal to A square. I write it here in the next page so that we can see 2B square is equal to A square. Right now in the above step we said A is equal to 2C. I replace A by 2C. Simplify, it becomes 2B square is equal to 4C square, 2 2s are 4 and C ka square. So now we divide 2 and 2 right here. So B square becomes 2C square. So C square is equal to B square by 2. Now what does that tell me? Again, like before, B square is divisible by 2, or 2 divides B square, which is by arithmetic theorem, fundamental theorem of arithmetic says B is also divisible by 2, or 2 divides B also, which means B has a factor 2, or 2 is a factor of B. You can write it both ways. 2 is a factor of B. Okay. So B could be what? 2, 4, could be 4, 6, 8, 10, 12, anything, right? It could be 26, could be anything. So your B could be 26 also, 13 into 2. So any number multiplied by 2 could be B. Now we proved B has a factor of 2. We had proved A has 2 as a factor. So both A and B have 2 as a factor, have a common factor 2. But initially we assumed that A and B are our co-prime numbers, that is the only common factor between A and B is 1. So this is in contradiction to what we had assumed. So our assumption proved wrong, right? Our assumption proved wrong. So we can say that root 2 is not a rational number. Okay, because our assumption is wrong, that A and B are co-prime, they are actually prime numbers, they have a common factor 2. So our whole assumption falls apart, and so we can no longer say that root 2 is a rational number, and if it's not a rational number, it's a irrational number. Okay. So this is called theory of contradiction. Like I said before, in a basket you are given an apple and an orange. You are supposed to prove that the fruit given to you is apple. You say no, I will prove it, it's an orange, and then you fail to prove that it's an orange, then by default it becomes an apple. That's what we exactly did here. Thank you guys, and in my next video I will come up with the solution of proving that root 3 is an irrational number. Good luck and see you soon.